afternoon again. So here I am again to continue to discuss the rules in simplifying radical. And we are now in Rule 4. In Rule 4, make the radical as small as possible. We can still remember the definition of radical. Radical is the term inside or under the radical symbol. We can make it smaller. We have to do, like example number 1, the given is square root of 8. Would it be possible to make the radical smaller? Let's try. So the order or index is 2. We have to think factors of 8, wherein one of the factors is a perfect square. So we have 8 times 1 is 8. And we have 4 times 2 is 5. Let us write 4 times 2. What is 4 times 2? 8. Now, we can write this as square root of 4 using the properties of radicals times square root of 4. We separated it. This is a property of radicals. But what is the square root of 4? 2 times square root of 2 is square root. Or you may extract the square root of 4 right away. What is the square root of 4? 2. But 2 is not a perfect square. So we will leave it under the radical symbol. So the radical now is 2. Before the original is 8. So we were able to apply the rule for make the radical as small as possible. I'll give you another example so that we can understand it more. Number 2, let us involve variable. The square root of 9. X cubed y to the 5th 3 to the 6. Let us try first the 9. Is 9 a perfect square? Yes. So we can have 9. For the x cubed, we can have x squared times x. For y to the 5th, we can have y to the 4th. Multiply by y. Let me erase this. Please allow me to use my finger. And I will enclose this into parentheses. What about 3 to the 6? Is this a perfect square? So we will have 3 to the 6. You will notice the term inside the parentheses are not perfect square, meaning they will be retained inside the radical symbol. Now, let us extract the square root of 9. What is the square root of 9? 3. What is the square root of x squared? S. What is the square root of y to the 4th? Y squared. What is the square root of 3 to the 6? 3 cubed. Times the square root of inside the parenthesis x inside the parenthesis. Or if you want, like what I did in number 1, using the properties of radical, you will have the square root of 9x squared y to the 4th 3 to the 6 times the square root of xy. If you multiply, remember, this will be x cubed. You will have 9x cubed. If you multiply y to the 4th and y, you have y to the 5th. And having 3 to the 6, you will have the original given. You extract the square root of 9, you have 3. You extract the square root of x squared, you have 5. You extract the square root of y to the fourth, the result is y squared. And extracting the root or the square root of 3 to the 6, you have 3 and this is 2. In this case, we were able to apply again the rule 4 to make the radicand as small as possible. Let's go to example number 3. I prepared 4 examples. In this case, I'll give you a cube root. Cube root of 54. What are the factors of 54? We have 54 and 1. What else? 9 times 6. What is 9 times 6? 54. But the problem, the index is 3. 9 is not a perfect cube. 6 is neither a perfect cube. We have to think factors of 54 wherein one of the factors this time is a perfect cube. Why? Because the index or order is 3. What else aside from 9 and 6, aside from 54 and 1? Cube root of 27 times 2. What is 27 times 2? 54. Is 27 a perfect cube? Yes. We can extract the cube root of 27. That is why we did not use 9 and 6. I hope you can follow. Now let us extract the cube root of 27. Or if you want, you may have, applying again, one of the properties of radical, you will have the cube root of 27 times the cube root of 2. Then you extract the cube root of 27. What is it? 3 times the cube root of 2. Or if you want to extract the cube root of 27 here right away. What is the cube root of 27? Times the cube root of 2. So it depends on the index. In the rule, if it's possible to make the radicand smaller, we are required to do it or to simplify. I'll give you my last example, which is example number 4. In this case, I will include variable, the cube root of 16 x cubed y to the 4th z to the 10. Let us first concentrate in 16. Would it be possible to use 4 times 4? What is 4 times 4? 16. But is there any a perfect cube between the same number 4 and 4? None. So what factors of 16 we can have? 8 and 2. So we will try. We will have the factors of cube root of 8 times 2. What is 8 times 2? We have 16. What about x cube? Is this a perfect cube? Yes. So we just copy. What about y to the 4th? Is it y squared times y squared? Is y to the 4th a perfect cube? So what factors? Y cube times y. Have you noticed that those who are not a perfect end root, I leave it inside the parentheses so that I will be guided that those terms that are inside the parentheses are not a perfect cube, or in order to be generalized, not a perfect end root. What about 3 to the 10? What can I have here? 3 to the 9 times 3. Take a look. If you will notice, the product is 3 to the 10. 8 is a perfect cube. Is x cube a perfect cube?
Yes.
What about y cube?
Yes.
What about z to the 9?
Yes.
Therefore, we can extract the cube root right away. What is cube root of 8? 2. What is cube root of x cube? X. What is cube root of y cube? Y. What is the cube root of z to the 9? Z cube times That is how we read it. Times the cube root of 2y z. And that is the final answer. Or if you want, you can separate again within the properties of radical. Applying the properties of radical. One of the properties, rather. And this is rule 4. So far, we have 4 rules already. The rule 1, we have remove the radical symbol whenever possible. We have the rule 2, which is all about make the index as long as possible. We have the rule 3, there should be no rational radicals, or the denominator cannot be in the form of radicals. And we have now the rule 4, which is make the radicand as small as possible. In the last rule, in the 5th rule, we will have the rationalizing the denominator by its quantity. See you again in rule 5. Thank you very much, and I hope you learned something.